I'm going to talk about cross-laminated timber. It's a relatively new structural system that hasn't. It's just been introduced to Ireland. It's quite common across Europe. It's a timber frame system. But before I talk about it, I'll just tell you who we are. We're an architecture firm, but we're also based in the School of Architecture in UCD in an organisation called Studio 13. That's there under license to UCD, and we're providing digital fabrication services to the architecture students, and we're interested in the whole area of digital fabrication. But we also run a studio there, and within that studio there's an architecture practice called Jackson Groark with a particular interest in digital fabrication. So we're bringing one of these houses to Ireland in the next month or two, and I just want to talk about it a little bit. So the context, one of the reasons it's interesting is because it's digital fabrication, there are links to off-site construction, and in the context of us needing so many houses, it's certainly possible to deliver really high quality housing in a very short time. The on-site time is very short, but they say the construction phase to get it, the structural part of it up, usually is something from 1/4 to 1/2 of the normal time under a concrete structure. So it's in that context. And of course, while we need lots of housing, there's also this imperative as we move on to get lower carbon, and there's a continual drive to bring carbon output, to reduce it, and that's something that can easily be delivered through solid timber structures. So it's in that kind of broad context that we think this is a technology that will find its way into Ireland and become very popular. So what is it? This is what it's not. That's timber frame. It's the normal sort of platform stick frame system that's very popular. Up to 30% of housing in Ireland. Very good system, very fast, prefabricated off-site, and we're all pretty familiar with it. But this is generally done as a system with OSB that acts as the shear panels on the side, whereas cross-laminated timber is a solid system. They're solid timber, and it's sometimes described as massive ply. So it's like you lay down all these timbers and then go the opposite direction, and each layer is glued. And you get this solid system up to 400 millimeter thick, these solid walls that are then put through these incredible machines that cut out all the windows, all the doors, they'll run the chases for all the services. All of that is done in advance in a factory. And it's all digitally designed in advance. So we actually do that. We've had to kind of learn those skills. So next week, for example, we're putting together the actual CAD drawing that will be sent to the machine that will cut out this house in Austria, and then it'll arrive 8 weeks later, hopefully correct. So that'll give you a sense of what it's like on site. They come in, they're craned into position, and you can see there on, I don't know if this shows it, is the hand moving. You can see there in the kind of European system, that's how they have their sockets. So you run these chases in the factory, so when it arrives, all of the sockets, light switches, everything is ready. So you're immediately into first fixing without any chasing. And it makes the transition from, for the various subcontractors, very, very quick and very predictable. So you end up not having as many issues on site, is one of the advantages. It can be done as a fair-faced finish, so you're showing the actual timber, in which case all of that routing is done in the second last layer. So you do all of that, and then you put another layer over on top to hide it all. So there's lots of flexibility within it. So these are just some of the images of them being pulled into place. The advantages of it, there are hundreds of thousands of these buildings across Europe. It hasn't come to Ireland yet. Most of the manufacture is situated in Austria. in a small area in Austria, you have these multi-billion euro companies that provide this, people like Stora Enso and KLH, and hundreds of thousands of houses have been built this way. There have been changes in the regulations, which has helped quite a lot in that you can now build up to 10 stories plus, and there are many examples in the UK of 10 stories plus being built in this system. We have a particular issue in Ireland in that for combustible products you can only build up to 4 stories. So that's something that I think will change. There's been so much of this happening throughout Europe, and the European technical approvals are there for fire and seismic activity and so on and so forth. So you will see a change. You also have lots of flexibility in terms of spans. You can get clear spans of up to 10 meters on floors, and so on and so forth. And it sequesters carbon, which is the key thing. There's a certain amount of cost certainty with it because you get all the design done in advance. The speed of construction, I'll show you some examples in a few minutes of multi-story units that have been built using this system and the time it took. But more than anything else, as we move on with the regulations, it is much easier to comply with the carbon prerequisites that we're going to have by 2020. Okay. And that gives you a sense of the carbon footprint of timber, which is usually a sequester of carbon as opposed to some of the other systems. Okay. Because it's a faster construction and there are no wet trades, you get significant savings on site. And once you get beyond a certain critical mass in terms of the size of the project, there are savings of approximately 5% overall. And these are the various approvals. It has European technical approval. You obviously have much better insulation standards. It's naturally airtight, so it starts to comply with, makes it very easy to comply with Part L and things like that. It has very high acoustic performance, and so on and so forth. Okay, so it meets that kind of dual thing of fast and affordable building while still being able to meet the requirements of Part L and the ever-reducing carbon imperatives. So these are some of the projects. This is in London. This is, I think it's 8 stories over a plinth, over a concrete plinth. The superstructure was erected in 27 days. That was just done a couple of years ago. 29 apartments in it. So this is another one. This is in Hackney in London. The program with the CLT there was 12 weeks, and it was estimated to be approximately half of what it would have taken if they'd used traditional construction. And there's more in Finland and so on and so forth. You can see there that internally you have the option of having that fair-faced finish. This is a project that's under design and planning in Sweden at the moment for 32 stories using this system. So that's it. This is a project that we're doing ourselves. It's designed in Revit, so it's a 3D kind of model. It's been built. It's a fairly traditional form, built in this very high-tech system. And that is going to be delivered on site. It's about 450 square meters of a house. It's going to be delivered on site next week. It's going to be erected in 3 days. The superstructure is immediately then clad with insulation and then rendered directly onto that insulation with a breathable render. So you have a breathable insulation, breathable render, and the timber itself is hygroscopic, so it breathes as well. It's one of the advantages of the system is that it sort of sucks in moisture and releases it through the day to give a very healthy environment. So that's coming on site hopefully sometime in the middle of next month. It's the first one in Ireland. It's a zero carbon structure, very easy to achieve A rating and passive house standard with it. And as I say, it's a 3D built time for the structure. That's it. Thank you very much.